Good everyone, my name is Anthony Nathaniel, and today I'll be giving you a course in chemistry. We'll be covering the entire of chemistry in a couple of videos. In this, starting from this video, and this is the first video I'll be dealing with. And the name of this course is chemistry. So this is chemistry for secondary school and for other lower levels. So in case you are in secondary school or maybe you are in junior school, you want to have a time ahead to understand this secondary concept, or maybe you are a tertiary institution, you want to go to the university, you can also use this course to brush up. So in this particular episode of this course, which is the first episode, we'll be talking about an introduction to chemistry, and then I'll be giving you um, explanation of what changes entail. We're talking about elements and mixtures, and then we'll be talking about separation and purity. So without wasting much time, let's delve into the matter. Now, chemistry is basically the science that deals with chemicals. So, and these chemicals are materials that we cannot see. You can't see the enzymes in your body, you can't see the chemicals that act on your food. So now, these chemicals, when we study the nature, the property, the reaction, the uses, and the form of these chemicals, when we study them, both their physical and chemical properties and then their behaviors, it is known as chemistry. That is chemistry. So chemistry is simply the study of the nature, reaction, properties, uses, behavior, and all the rest of chemicals. And we have what we call people that study this nature. They are biochemists. We have biochemists. We have chemical engineers. We have pharmacists. We have even medical doctors. They have a satisfactory knowledge of chemistry. So now in this foundational course, we're going through chemistry, the whole of chemistry, as I said earlier. So now the first thing we want to talk about is change. Now the reason why we are talking about change first is that there are different chemical substances. So you have to understand how one substance is changes from one form to another, so that you will not begin to mistake something for another thing. For example, if I put a bowl of water and I put a bowl of ice, now and I ask you which of these one is water, you will say water, but actually both are water, but they are just different forms of water. That is just an example of the mistakes we could make if we don't understand the changes that matter goes on. So let's talk about that. And now these changes, they are in two types. They are physical and chemical. Now the physical changes are changes that are reversible. For example, when you freeze water in a bottle, when you freeze in your refrigerator and then you freeze it, that water comes out as ice, right? It becomes solid. Now that is called the solid form of solid phase of water. So when we talk about the different forms of a substance, we call them phases. PHASES, they are called phases of matter. So moving on, those physical changes, they are simply reversible. And example of those physical changes, as I mentioned earlier, is the conversion of water to ice, and that is also known as freezing water. So and that ice is a solid form of water, while the water itself, which we know as general water, it is a liquid form of water. So the next time you are asked, or next time somebody asks you, is ice water? Then you say yes, ice is a solid form of water. So moving on, let's move on to chemical changes. Chemical changes are the changes that occur and are simply not reversible. So now this is the major difference between physical changes and chemical changes. Physical changes are easily reversible, but chemical changes are very, very difficult to reverse. For example, one example of chemical change is combustion of your gas. Many of you use this gas in your cylinders at home. Now you might not know, but your gas is basically a substance, and it is a hydrocarbon. It mostly consists of butane or pentane. Now that butane, majorly butane, which consists gas, or sometimes it's often propane. Now that gas, when it goes out of the cylinder, it combusts. And in a later video, further in this episode, we'll be talking about combustion and other reactions. So when that gas combusts, or when it burns in air, it forms a substance. That substance, it is liberated as heat. Some of them liberated as heat, some of them liberated as gas, and so on and so forth. For example, let me give an example of such thing, so that in case you meet it later in this episode you have a knowledge of it. Now in fact we have CH4, or rather let me talk about butane, which is your cooking gas, C4H10. Now this is called a hydrocarbon because it consists of two elements, namely carbon and hydrogen. So those particular types of chemical substances, they are known as hydrocarbons. Now if we combust this one, and as I mentioned earlier, combustion is the combination of a substance with oxygen plus O2, and oxygen is always in 2. I will explain later why that is. So it forms two major products, which is carbon dioxide and water. Now this water that is formed is in a gaseous form. So you open your brackets, put G under the H2O. Then the CO2 is also gaseous. That's carbon dioxide is gaseous. The oxygen is gaseous, and then the butane is also gaseous. Now this reaction, there's what is known as balancing of reactions, which I will not talk about in this episode. We'll talk about in the later episodes of stoichiometry, but this is just the basic way of understanding how a chemical reaction occurs. So whenever you burn your gas, can you go to the air and pack the gas out back into the cylinder? No, because once you burn gas is gone. You have to refuel by buying new gas. So that alone is a very, very solid and practical example of a chemical change in every day of our homes. Like, look at gas, yes. So now moving on, we have what is known as elements and mixtures. Now we've talked about chemicals, right? Now it's now time to classify these chemicals into different forms. They are what's called elements and mixtures. Now an element, now if I talk about an element, you say someone is an element, it's an element of disturbance. Now that element simply means one, something that cannot be broken down into simpler units. An element is a chemical substance that cannot be broken into simpler substances by any known chemical means. Though I'm not trying to say that it is not impossible, but by any known chemical means it is not possible. You know that for now scientists keep improving techniques in chemistry, and we might hear in the next 10 years that there is a method of breaking down elements, and which there actually is, which we'll talk about in radioactivity. But for now, for the basic chemistry, elements cannot be broken down. So just understand that. Now, example of these elements are the oxygen I talked about here. Oxygen, anytime you see a symbol in chemistry that has only one letter, because these chemicals, they are often represented by letters. There is a classification of the nomenclature of chemical substances, which was put up by Berzelius in the 19th century. So now this method, we have different names of classifying these elements. But once you see that there's a single capital letter or a single capital letter and a small letter, that is an element. But if you are seeing two capital letters, just like CO, this O is a capital letter, CO, C and O, those are two elements. So now this O on its own is called an element. Why? Because it cannot be ordinarily broken down into another subparticle. Though it has subparticles, but they are not able to stand on their own as new elements. So moving on, we have what is called mixtures. Now, elements and compounds. Now the opposite of compound, lest I forget, compounds are the chemical substances that consist of two or more elements. So I knew that element is a single unit of chemical substance that cannot be broken down, but compound consists of the combination of elements. For example, when your carbon, hydrogen and oxygen combine in a certain way, they form glucose, which is an aldehyde. And when they combine in another way, they form fructose, which is another form of sugar. So that is under organic chemistry. We'll talk about that later. But moving on, let's focus on mixtures. Now, after we've talked about these elements, we'll have to talk about compounds, and compounds are a combination of elements. Now we'll talk about mixtures. A mixture is basically when you have two or more elements, two or more compounds combining together. But in this case, they are not reacting together. Now, when they are reacting together, it's called a chemical reaction, and it forms a new compound. But when you have a mixture, for example, let me give a popular example. If you've passed through the lower basic classes, which correspond to JS 1 to 3 in Nigeria educational system, you would have understood that air consists of nitrogen, oxygen, carbon dioxide, rare gases or noble elements, and so on and so forth. Now that nitrogen and oxygen in the air, they are mixtures. The air is basically a mixture. So that mixture, as I'm talking about them, they do not react together. They are just in the same compartment. Just like when you have someone who you don't know before, you don't talk with the person, you just pass the person. You don't have any close acquaintance with the person. That is like that's just like a mixture. But when you have people you are very very related to, like a family, I can say my family is me and my family will form a compound, but me and my non-family will probably form a mixture. So that's just an abstraction and explanation of that difference between mixtures and compounds. And don't forget, elements are single units; they cannot be broken down. Moving on, we have for these mixtures. Now there are differences between mixtures and compounds, but the major difference between mixture and compound is that a mixture can be broken down easily. Why? Because when you have somebody who you don't really bond with, it's easily for you to leave the person alone. Like, okay, you don't feel any kind of emotion when you let the person go. But when you have someone who has a lot of affiliation with you, you kind of have a hangover and emotional stress. So that is the difference between elements and compounds. So the elements that make up a compound, they are chemically bonded together, and so they find it very hard to separate. So they are very difficult to separate. Whereas the elements that form the elements or compounds that form a mixture, they are very easy to separate, and that's where we'll be talking about now, which is called separation techniques. So whenever you separate these elements of mixtures, it's called separation techniques. So now that's the last section of the video which I will talk about. Now separation techniques occurs only in mixtures. So if it comes to your examination, like you have two substances, and maybe you have CO2 and air. You have CO2 and you have air. And then if we ask you which of these can be separated by separation techniques, so you shouldn't pick the CO2, which is carbon dioxide, because CO2 is chemically combined together and it is a compound of carbon and oxygen, and as such the components are very very tightly packed together that they cannot be easily separated unless by extraordinary means. So and then we have this air. This air is actually a mixture, so you can easily separate air. And in a later series of this video, I will talk about fractional distillation of air to produce oxygen. So just stay tuned and watch this series to the end. Now this air, as I said, is a mixture, and we could separate the components of this air by what is known as fractional distillation. Now, if you have attended junior school, you will have heard of distillation and fractional distillation. They are simply methods used to separate different solvents, and those solvents, they are mixtures. So those solvents, they do not react chemically together; they are just mixtures. So get that very very, because this is the basic and this is the foundation of chemistry, which you must understand. Now, these separation techniques, I'll talk about a couple of them. For example, there's a staple food in Nigeria known as gari. Now, whenever you soak gari in water, the gari often settles down at the bottom, and then you use your spoon to scoop it, and then yummy. So now that gari and the water is a mixture, and a very simple way of separating them is by filtration. So or rather, you can even use what's called decantation. So basically, filtration and decantation, I will explain them. Filtration is basically when you make use of a filter paper. So a filter paper is basically a special type of paper with a very very tiny holes. So and those paper, when you pour a mixture in it, the solvent passes through while leaving the solute behind. So that solute, which is not soluble in the solvent, will be liberated. So and many of these, if they form in suspensions, it can also be separated. So that's separation techniques. Filtration is used for separating a solute from a solvent. Now then we have decantation. Basically, it's very simple. When you leave a mixture to stand, the heavier particles will get to the down, and then the lighter ones will go up. So you can, after you leave them for some time, you can use it to separate. I personally use that a lot when I'm eating a mixture of food substances, just like gari, as I mentioned earlier, and I don't want to take the water, so I can just let it be stand, and then after some time you pour the water out. That is called decantation. So and then apart from that, there are several many separation techniques, but which I will not really delve into today because they are things that they are actually technical. So the simple ones are filtration, decantation, centrifuging. So and that centrifuging, it is used to separate components of blood. We also have chromatography, and that is used to separate components of mixtures. And that mixtures, they are often soluble in one another, like components of blood, components of ink. So then we have different many other. We have a magnetization, we have different precipitation, crystallization, and all the rest. So hopefully we'll be taking this episode to another series in another video. But I've come to the end of this video right now, and let me give you a summary. Today we talked about physical and chemical changes, we talked about elements, compound, and mixtures. Then finally we talked about separation, and then that is the end of this video. Thank you very much for watching, and see you in the next episode.